What's up? Good morning. Yeah. Today we're gonna be doing triangle congruence. They call me the mathemaLIMPIN. What's up? I'm the mathemaLIMPIN. If you need a problem, I can't fix it because I can't run. Let me ask you one thing. Yay math?
Yay math!
Very good. Very good. That was good. I felt like wind. You know? All right, so the purpose of today's lesson is to prove triangles congruent, right? And that's what we're going to spend the next 20 minutes doing or so. So we want to prove these two triangles congruent. What does congruent mean, real quick? Equal, the same, completely identical, right? All right. One of the ways of proving triangles congruent is by this law called ASA. And we're going to talk about it now. So let's say right now, are these triangles congruent yet?
Yep.
No.
No, they're not. Okay, so let's see. Let's use the red. So now they have one congruent angle. Are these triangles congruent yet?
No.
No, because you could have triangles that have one congruent angle, but their bottoms are all crazy, you know, and they're very different. So these triangles are not congruent yet. What about, now they have one congruent angle and one congruent side. Now are they congruent? Do you think?
Yes.
No.
Almost. They have one congruent angle, here it is, in the red, and they have one congruent side, here it is, in the green, and let's do this. Now this is marked with like 2. Okay. Now look closely. They have one congruent angle. They have another congruent angle. And they have a side between them that's congruent, just like it's spelled. Now, can you guess, are these two triangles congruent now?
Yes.
Yes. Question, please. Okay. I will never mind. So yes, these two triangles are congruent, and they're congruent by the law ASA. What does ASA stand for?
Angle, side,
Angle, side, angle. Very good. So we could say these two triangles are congruent. If they have anything less, then they're not congruent. That's the point. So let's draw two more. So these are congruent by ASA. Next two. All right, you can draw them however you like. Let's do them side by side. Make them look like slightly non-equilateral. And so we ask, are these triangles congruent yet?
No.
No. Question?
Did you say that the ASA is only for two triangles?
Well, any triangles can be congruent with ASA, as long as they have the ASA relationship, as in an angle congruent, a side congruent, and another angle congruent. And just like it's spelled, this is something that students miss. Just like it's spelled, the S is between the two angles. See, check it out. See how the green one is between the two angles here and here? That's ASA, right? Just like it's spelled. Now we're going to do another one. Okay, so these triangles aren't congruent yet. Let's do this angle congruent to this one. Are they congruent? No. Let's do this side. Again, congruent to this side. Are they congruent yet still? No. Now we're going to make them congruent by AAS. So notice, the side is not between the angles. So which side should it be? Do you think it should be, or excuse me, which angle should it be? Should it be this angle?
No.
And this? Or the right one, please, in the back?
Bottom right.
Bottom right, that's right. So let's put them in. You guys, good job. I'm glad you're volunteering. Don't be afraid to be wrong. Seriously, it's all good. I'm wrong all the time. It's too bad I'm a teacher. Not good. Yeah. So, but I'm teaching you how to be wrong, so that's part of me. So it works. Spell it! It's fine. Never thought of that before. That's cool. So check it out. Two angles that are congruent. There they are. Two angles that are congruent. And a side that's not between them. This the side that is between them. This side is not between the two angles. So are these triangles congruent now? Yes, by AAS. Okay. Any questions? So we're moving on. AAS. Okay, good. So let's try some more. Let's draw two triangles like this, kind of back to back. Back to back now. All right. The goal of this lesson and every lesson following it will be to prove two triangles congruent. Two or more, as you said, Cornelius. So, no, that was a joke, I just made that up. So are these triangles congruent? Even though they're back to back, you know, are they congruent to each other yet?
No.
They're not, they're not. All right, so let's see if we can start marking them. Let's use the red. Yeah, question?
If you prove only the top, oh wait, no, if you prove the two bottom sides equal,
These? Yeah.
Wouldn't that prove that it's congruent? Or do you
Not
have to do
enough.
the top too?
Not enough, yeah, we'll walk through it. Walk through it. Right now, it appears that there's nothing congruent about these two triangles. It appears. But the secret is there is one thing that's congruent about them. So start to think of that in the back of your mind. So let's say if I said this angle was congruent to this angle. So now, do they have an A or an S shared? A, very good. They have an A shared. Now let's do here. Now these are explicitly 90 degrees each. So do they have another A or S?
A.
Which one is it? A. Okay. So it looks like they have an A. We have another A. So we need one more, don't we? They come in threes. So we need one more. Does anyone see that there's another one in there hiding? Okay, two people. It's okay if you don't. Keep looking. There's another one in there hiding. It's either another angle or a side. Can you see which one it is? Yes.
So is it the middle one?
This side here?
Yeah.
Yeah, why? Why is it? You're right.
Because they both share it.
They both share it.
Keeps it.
Yeah, yeah. So isn't the goal to prove this triangle congruent to this triangle? And so if we're proving this triangle congruent to this triangle, we say, okay, well, this side, I usually mark it with 3 so it stands out. This side for the left triangle is the same as this side for the right triangle. So these two sides are shared. They're back to back, so they're the same. Any questions about that? This property, does anyone know what it's called? When you look at yourself in the mirror, you see your?
Reflection.
Yeah, so this is called reflexive property. Reflexive property, like if we were to say, if we were to call this side AB, you would say AB is congruent to AB. And this is called the reflexive property. That's something you need to learn. Reflexive property. And the way I remember it is, if you're looking at yourself in the mirror, AB is looking at itself in the mirror. You know, this is like Albert Barenthal, whatever. Albert is looking at himself in the mirror. Why do I think of that name? I have no idea. Albert's looking at himself in the mirror, sees his own reflection, and there it is, reflexive property. It's a good way to remember. Yeah?
Then would AB equal BA? Would that be also reflexive?
Sure. Yeah, same thing. Because it's the same line. Okay, so now, are these two triangles congruent?
Yes.
Yeah.
By which law, please?
ASA.
ASA, that's right. And we can tell it's ASA because the side
Is in between the
is
two.
between the two congruent angles. Just like it's spelled, the side is between the two angles there. Questions? Okay. All right, good. We're moving along. Let's do another one of these, back-to-back ones. Okay, line coming down. Okay, are these triangles congruent yet?
No.
No, they're not. So let's do, I want to time it so I know, I want to introduce it little at a time. Okay, what about now? Are they congruent now?
No.
No, right? How many things do they share so far?
One.
1,
Two.
2. 2, right. They share one angle, and they share what else?
One line. Reflexive.
A side. You know,
Right.
why don't we do the side right now? Let's do it. I think it's a good plan for you on your quizzes and tests to say immediately that this side is shared and it's the same as itself so that you can get closer to your goal. Please, yeah.
Well, wouldn't the bottom line also be a shared side?
Good question. You're saying, wouldn't this be the same as that?
Yeah.
Not necessarily.
Not necessarily. What if we had something like this? See that? This side is not the same as that. So until we explicitly say that this is the same as that, we can't assume that it is.
Okay.
All right? So that's a good thought. That's a good thought. I'm sure many people think that. It appears that they're the same, right? Oh, I think this is the same. They are, but we can't say that, right? Same with this. I think these are the same. Let's say that they are. We can't. We can't say that these are both 90, because it could be 91 and 89, you know? We can't say that these are the same, just like we can't say these are the same. We can't say it until we know it. Please.
Can't you say that the middle is 90 because you have the two bottom angles?
I said, what if this was 89 and 91?
But if the two sides are the same, then doesn't...
Which two sides?
The two bottom
These two?
angles.
Not necessarily. Look, I'm glad you asked. These two angles are the same. That's possible. But that doesn't have any influence on these two. Right? So you guys, these questions are good. They're really going to help you get ahead, you know, because you understand it from the bottom and the top. So we can't assume anything's congruent until we can conclude it. So far, we can only make two conclusions. The one that I told you, the red one, and the one that you told me, the side that's equal to the side. All right. And now, let me ask you, what would need to be the same now? This is what a lot of homework assignments do. What would need to be the same for these triangles to be congruent by AAS? AAS. I see an A and I see an S. Please try.
Is it bottom?
This one?
Yeah.
These two angles? That's right. So they have to be 90 each because they're supplementary. We see that. We see that. We know they're supplementary, so they have to be 90 each. So can you give us an explanation in your own words? Why, now that these are the same, that these triangles are congruent by AAS? Can you try?
Why?
Yeah, why? Why did you say these?
Well, because the two angles on
right.
the sides,
Right?
they it has to be like that.
That's right. And then what can you tell me about the side? Is it between them?
Reflexive.
Is it between the angles or not between them?
It's not.
It's not, right guys? It's not. Just like the side is not between the angles, here it is, the side is not between the angles. Very good. Okay. Let's keep going. How far are we in time-wise, Cornelius? Cornelius.
Wait, like on the
12
video?
minutes and 30
12.
seconds.
We're so good. Good job. We're making good time. Okay, so what about... We're doing two more. All right, let's do back to back. And now, are these triangles congruent? We can
Not
go a
yet.
little faster.
No.
No, not yet. What about, now are they congruent?
Not yet.
No, not yet. What else can we assume?
That
Middle line.
Middle line, what's that property called?
Reflexive.
Reflexive, oh brav. It's bravo backwards, whatever. And that's great. Tell it to the officer. It's like, whatever. Like, okay, whatever. That's a joke. That never happened. Okay. So are these congruent yet?
No.
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 What if I said that this segment is the same as that? Now, are these two triangles congruent by any of the rules that you see above?
No.
Yeah.
Yeah.
No.
AAS.
No.
AAS. Well, are
ASA.
two sides the same or two angles the same?
It has to be 90
Sides.
degrees.
These are sides, right?
No.
So if I were to make letters out of this, what letters would they spell? Be
ASS.
careful. Yeah. How about the other way around? Okay. Wouldn't it be funny if I wrote that and then someone walked in? I'd be like, hey, yes, so any questions?
Well,
So here's the point why I brought this up. Let's put it down again. Okay, this order or the other order, right? The other order. They do not prove that triangles are congruent. If you have this situation, we cannot conclude that triangles are congruent. So you can do something like this. Not congruent. Not congruent by SSA. SSA is not a valid triangle congruence one. Please.
Could you just write no conclusion?
Right, right. We can write no conclusion. We can write, because there is no conclusion we can make. Specifically,
They still could be.
excuse me?
They still can be congruent, just not based on SS.
You know, you're absolutely right. That's right. That's right. I stand corrected. I'm glad you did that. That was great.
What was
That's
the
why-
question?
That's why A math is awesome. just because these are SSA, these may be congruent, but they're not necessarily congruent. That's a very good point. I was wrong about that. These two can be congruent. There's nothing stopping them from being congruent, but we can't conclude that based on SSA, so we say no conclusion. That's right. Good job. All right. One more. Wa.
Mo.
Mo. One more. Oh, we didn't color the comma!
No. Just have a hand. Just have a hand.
Problem solved. Okay. So, you guys, several of you sent me emails last night saying, can we please do a proof today? So I want to honor that request, and we'll do that. Everyone's looking around like, who was it?
Yeah.
That's a patented teacher maneuver of turning the class against each other. They do it in jail. In the movies, I mean, you know. Remember? Remember? No, just kidding. Okay, so we want to prove these triangles congruent. Let's do it. Let's say in the given statements, reasons. Let's go B, A, B, C. Okay, so what do you think? Remember, the purpose of this entire lesson, as we do our last thing today, is to prove triangles congruent. What would be the prove statement? Please try. Prove that.
BCA.
What is BCA?
A triangle.
A triangle, okay. Triangle. Can we do the A in the middle just for my purpose? I like the. Okay, cool. So how about B?
BAC
Prove that triangle BAC is
congruent to.
congruent to.
Do you still want A in the middle?
Now it has to be because it should be in order in
Okay.
terms of it. Yeah.
CAB.
Try again.
DAC.
Yeah, right. See it? And
okay.
top, bottom, and top, bottom. So that's triangle DAC. Back and DAC. So we want to prove these two triangles congruent. What are the two ways we learned today of proving triangles congruent? Yes?
ASA and AAS.
Right. So our goal is to get to one of these conclusions. So let's do some given statements. Given, we have angle B is congruent to angle D. That's one given. And we have AC, the line, bisects angle bad. All right, so there's our given. Let's mark a little space separation here so we can see what we're working with. Okay. That looks all right. Okay. So let's try to prove these triangles congruent by either AAS or ASA. Let's go through one at a time. Angle B congruent to D. Let's mark the picture. Right. Any objections? B, D. Okay. Oh, of course, this is the given, or as some people like to say, the given. Woo! Don't feel bad about yay math to the room. I just scream like a monkey. The walls are thin. But this is good because it's a bathroom on the other end of this. Boom, boom. It's like, ah! Okay, so this is the given. That's given, folks, just in case, you know. All right, are these triangles congruent? Can we reach our conclusion yet?
No.
No. Okay. What do you want to do? What do you want to do next? There's a couple things we can do. Please.
I'd do AC, line AC,
Yep.
or yeah, line AC is congruent to line AC.
Sure, you want to do reflexive right now?
Yeah.
Let's do it. AC is congruent to AC. I would do that too. I like to get it out of the way. Right, so we have AC is congruent to itself. By what property, Mr. Look in the Mirror Man?
Reflex.
Reflexive. Good. Reflexive. Prop. Okay, so let's mark the picture. Always, always, always mark the picture. Don't be that student that doesn't mark it. Because if you mark it, then you can see how closer you are. So I like to mark it with 3. You're free to do so as well, or whatever you want. Okay, so we can make our conclusion now. We have it. Do we have it?
No.
Dot, dot, dot? No, we don't have it. We don't have it yet. How many pieces are we missing? One, two. Yep.
I have a question.
Question, please. Loud so we can hear.
Okay, because it says AC bisects angle BAD.
Right, right.
Doesn't that mean that both angles are equal?
Which angles? You're right. Which angles?
Angle BCA and ACD.
I'm so happy you said that. BCA and ACD.
Right? The back
So these
and-
two.
Wouldn't that, yeah.
These two. That's a very good guess. It's a
No.
very,
Or
very
is it-
common mistake.
Or is it,
It's the top one.
top? Okay.
And can you explain why it's the top one? Can you explain why it's the top one based on this given? I'll stay below it.
Because if BAC is and CAD are in the middle of BAD.
Right. Right, right. See it? So BA, what is being bisected exactly?
BAD.
And what is BAD?
The whole
It's not a triangle. What is BAD right now?
It's a whole
It's an angle, right? It's an angle. So if an angle is being bisected, BAD is being cut in half. That's what it should. Cut in half. Like B bad, but less. So BAD is being cut in half, and we identify where angle BAD is. Angle BAD is here, isn't it? Okay? And if angle BAD is being bisected by this line, so the question I'd like to ask is, what is being bisected? We'll take it in a second. What will be bisected? Bisects BAD. So angle BAD is being bisected into two pieces. So we have a question here.
Yeah, why can't you just say the definition of bisect?
We will, that's the reason. But what's the
Okay.
statement?
No, but I mean like that, because that's the given,
Yep.
but that,
The definition of angle bisector will be here. But give me a statement of congruence. Here you have one, here you have two. Oh, by the way, it's a good point, good point. What I also like to do, especially for beginners, angle B is congruent to angle D. Is that an S or an A? A. So maybe you can go like this for yourself. It's not necessary, but you're welcome to. AC is congruent to AC. Is that an S or an A? S. So maybe you can go like this to yourself. And so we need one more. Please.
Wouldn't it be that
Yeah.
angle BAC is congruent to angle DAC?
Right. If angle BAD is being bisected, we can conclude that angle BAC, this one, and let's mark it with 2 now because this has 1. This angle is congruent to, what did you say? Loud?
DAC.
DAC. And that's this one. And now angle BAD has been cut in half. And so, in the back, you said, what would be the reason? Def?
definition of bisect.
Of what kind of bisector? Segments, angles, cupcakes?
Fine. Angles.
Angles. Angles. In this case. Because what is being bisected?
Angle BAD.
I heard the word angle, that's right. Definition of angle, bisector. Is this an S or an A?
A.
A. All right, there's A. Okay, can we now conclude that these triangles are congruent? Yes?
Why is it an angle being bisected and not a triangle?
Because that's what the given says.
Oh.
AC bisects angle BAD. We're trying to prove stuff about these triangles in order to state that they are the same. All right? And so now, can we conclude? Let me ask a more difficult question. What can we do now? Less direct. Out of the way. Here we go. Okay. What can we say now? This is always funny. I want to like get it right when the hand's up. I got you. Okay, go. What? Try. You can conclude what?
You can conclude that.
Hand off the mouth.
You can
Okay.
conclude that triangle BAC
Okay.
is congruent to DAC.
What DAC?
A triangle.
Triangle D.
DAC.
AC. What is the law that allows you to do that? In this case,
The law
The moment of the end, right?
Yeah.
Neighbor,
The AAS postulate.
AAS. Please explain why.
Because there's the angle in the bottom left, the angle at the top, and then the shared line of AC.
Okay.
And the line isn't in between the two angles, so it's not ASA.
The line is not between the two angles. Notice, these are the angles he sees. This would be the line between them that needs to be congruent, but it's not congruent. The line outside the two angles is congruent, thus it's AAS postulate. Okay, questions please, feel free. Yes?
Whenever it's a proof for triangles, are there always only going to be 4 steps, or will it vary?
You know, more or less. I'm hesitant to answer that question outright because it depends on what the given is. But I will tell you that you need to make 3 statements of congruence that match these 3 letters.
Okay.
Then you can prove that triangles are congruent. That's the goal. 3 statements of congruence, either angles or sides. All right, good question. Anything else? All right, good. Thank you, everyone. Give yourselves a hand. Okay, you can cut it. Cut it. Bye. Say bye. Say bye.
No, I want to do it.
I want to do it.
I wanna
Do it. Yeah.